Summary, going real quick for the fans out on YouTube. First law is the gain or loss of amount of energy is equal to the amount of heat transferred. And our first question is, where does heat flow? It goes to a well-defined group of atoms, which we said is a system. All right, so you're adding another question. You don't like this one?
Yeah, that one's fine.
That one's fine. Okay.
What does the added heat go to?
Or what does it do?
What does it do?
Yeah.
Increases internal energy or increases the external work.
Okay, so what does the heat do? And this is a really important one. Like, when heat transfers into an object, what is heat actually doing? And it's doing one of two things. It's either increasing internal energy, or it's doing work. Those are the two things. It either does work or it changes internal energy. So, for example, it can go, if you heat something up, it can change the energy that it has. Okay? So, like boiling water changes the water's internal energy. But what else can it do? It can also do work. When we boil water, it turns into steam. We can use steam to move power generators and create electricity. So, not only does it change the internal energy, but it can also have work done as well. Good. So what does added heat do? Increases the internal energy or increases work. Okay?
What is the type of appliance of this principle? Tasked to doing mechanical work and raise an internal energy. What's it say?
So what is an application of this? So an application would be some task that does mechanical work and raises internal energy. So it does work, so something that does work and it causes the internal energy to change. So work is done on something and then internal energy changes. Okay, this is going to preview the next group. Car engines. Or as they're called, heat engines.
Like combustion?
Yes. Was that your sound of what an engine makes? That was very good. It was
Will's truck.
Yeah, that is what Will's truck sounds like. Got to sputter and cough a little bit too in there just to keep it realistic.
Inline 6 is just great.
Yeah, that's right. All right. Good. All right, clarify for me.
When you gain or lose energy. Oh, God. You lose an equal amount of heat.
Yeah. So when you gain or lose energy, you gain or lose an equal amount of heat. So this is a good thing to clarify. So this right here is called the conservation. Yep. So, Mr. B, what you're saying is the zeroth law is basically just a translative property of math where A equals B, B equals C, C equals A. Yes? So what you're saying, Mr. B, is that the first law is just the conservation of energy. And you are absolutely right. The first law is just the conservation of energy. Yep. It's the conservation of energy. So what it says is that energy has to be conserved when you do work. When you do heat, when you do energy, when you do temperature. Energy has to be conserved. So if the temperature changes, something has to happen. It can't just magically change. You either have to do work on the system, have work done by the system, or transfer heat in or out. You have to do something to change the energy. So if the energy changes, something has to give. It can't just magically happen. Okay? So that's the idea. Energy is being conserved. So conservation of energy is really what all this is.
Crazy.
I know. Mind blown, right? All right, illustration. Oh, this is rich. Somebody explain what this is.
Believe it or not, that's probably the best picture I've ever seen.
Pumping up a bike. Okay, so what does pumping up a bike have to do with this?
Like it gains heat when you're pumping it up. The pump.
Good. So you do work. Transfers heat. I like how you think this is the best one. I mean, it's something. Yep. So you do work. Yep, you can see the handle. That's why I drew the do work there. So you do work to pump the handle. It transfers heat, and it'll change the temperature. So work is done, heat is transferred, temperature is changed. So conservation of energy. That is a picture. You're welcome. It is a picture. All right, does anyone have any questions for this group?